Hello everyone, and this one will continue for the second part of finding the critical points and extrema of a function. And our example this afternoon is somewhat different from the previous example that we have discussed in the previous video. By the way, in the description below I have attached the different links on the videos that we have, just in case it happened that you have not seen yet our video in the past. Then we have the link in the description. Okay, you may watch that during your vacant time. Okay, so I have here more examples for finding the critical points and critical number as well as the extrema of a function. So we'll have here more example. Okay, actually I have here two examples, and both examples are different from the previous one. Okay, so the first example will be find the critical points. Okay, this is very specific. Find the critical points of f of x equal to the square root of x squared minus 4. Okay, so before finding the critical points, we need to find the critical numbers, and the very first step to find the critical numbers is to find the derivative of this function, or to examine the possibility if there a possibility that our function will have a derivative in which it does not exist. Okay, by the way, before moving on, we will have first the domain of our function. What are the allowable values of x that we are allowed to substitute for x in order that our function will work and it will not commit an error? Remember, we cannot get the square root of a negative number, right? Right? Yes, we cannot have the square root of a negative number. Try that in your calculator. Say the square root of -9 and your calculator will blow out. Okay, so we are not allowed to have a negative number because we cannot extract the square root of a negative number, except otherwise when you apply imaginary numbers. Okay, so do you believe that we are allowed to have here some values for x like -2 or 2? Yes, actually that's the limit. So the domain here of our function is we're only allowed to substitute values that are greater than or equal to +2, or x values that are lesser than or equal to -2. Because if you'll substitute 1 here, and 1 squared is 1, 1 minus 4 is -3, and we could not extract the square root of -3. So, but if x is 2, 2 squared is 4, and 4 minus 4 is 0, the square root of 0 is 0. So our minimum value is +2, and our maximum value on the negative part of the number line is -2. So take note of this. Okay, that's it. So step 1, find the derivative in order for us to find the critical numbers. So the derivative of x of our function is equal to what? Okay, by the way, before moving on, we can rewrite this function. We can rewrite this one as f of x is equal to, in exponential form, x squared minus 4 raised to 1/2, right? Okay, I hope you understand that. Okay, so that it would be easy for us to find the derivative. So the derivative now of this function will be equal to chain rule, because we have the inside and the outside function. So 1/2, write the inside function, x squared minus 4 raised to 1/2 minus 1, that is -1/2, okay, times, what's the derivative of the inside function? That is 2x. Okay, now if we will simplify this result, this will be equal to this is 2x over 1, right? So we can cancel 2 and 2, so it will be retained with x times x squared minus 4 raised to -1/2. But if you would like to bring this -1/2 in the denominator, then we'll have here of course, the reciprocal. So this will be equal to x over x squared minus 4 raised to 1/2, or you can rewrite this one as x over, going back to square root, x squared minus 4. Okay? So this is now our derivative. Okay, but before going to the next step, by setting our derivative to 0, okay, we will examine first if our function has a possibility that our derivative will not exist. Because anyway, if we will solve this derivative now, actually this is our derivative. Okay, I will write here. Okay, so our derivative now is equal to x over the square root of x squared minus 4. So we will set this one to 0. Okay, so set this one to 0. So how do we set our right side to 0? Of course, in a fraction, if the numerator is 0, it will become 0. So in other words, if x is 0, then the derivative will be 0. So x here is equal to 0. Do we have any problem with that? Yes, we have a problem with that, because in our domain, we're only allowed to have a maximum of 2 or 2 upwards and less than -2, and 0 is not in the domain. So in other words, we cannot use this as our critical number. So this one is not a critical number because not in the domain. Okay, so the other thing that we'll be doing this time is to find the possibility for the derivative of the function that will have a function or a derivative that does not exist. Okay, so is there any possibility that our derivative of the function will not exist? Let's see. Okay, so the derivative of x does not exist if what? The denominator is, of course, 0. So x squared minus 4, we will set that to 0. By the way, if you're asking why do we set this x squared minus 4 is equal to 0, going back to our derivative, do we allow in a fraction to divide by 0? Of course not. Try to divide any number in the calculator and your calculator will explode if you divide that to 0. Let's say 1 divided by 0, your calculator will say math error. Okay, so when the denominator is 0, the derivative does not exist. That's why we have here x squared minus 4, our denominator previously. We will set that to 0 so that we can identify the x values that will make our derivative does not exist. Okay, so set to 0. How do we set that to 0? Okay, so how do we set that to 0? We will square this one, of course, because it's square root, the index here is 2, and if we will square that, the square root will go away. So x squared minus 4 and 0 squared is still 0, and we'll solve for x. So factoring, this will be x minus 2 and x plus 2. Alright, so x minus 2 is equal to 0, x plus 2 is equal to 0. The first value of x is positive 2, the second value of x is negative 2. These are the critical numbers. Agree? Yes, this is critical number 1 and this is critical number 2. Okay. Is this positive 2 and negative 2 belongs to the domain of our original function? Let's see. The domain is 2 and negative 2 inclusion. So included po. In other words, our critical numbers 2 and negative 2 is in the domain of our function. So we are allowed to use them as our critical numbers. Okay? the requirement in our problem is to find the critical point, and so far we have arrived only on the critical numbers. So to find the critical points, we will continue the process by substituting our critical numbers to the original function. Okay, so what is our original function? I will write this one again, original function, because in this original function we will substitute them our critical numbers. Our original function is f of x is equal to the square root of x squared minus 4, right? Okay, so our first critical number is 2. So if we'll substitute here positive 2, the answer would be the square root of 2 squared minus 4. 2 squared minus 4. That would mean the square root of 2 squared is what? 2 squared is 4, minus 4 is 0. The square root of 0 is 0. So the first critical point is 2, 0. Okay? The second critical point is negative 2. Here, the second critical point is negative 2. So I will find the square root of negative 2 squared minus 4, in which negative 2 times negative 2, the answer is 4. Yes, minus 4. And this is the square root of 0, which is 0. So the second is the first critical point. The second critical point is negative 2 and 0. So far, so good? Yes, so good. This is our first critical point. This is our second critical point. So we have answered the question in the problem that we are required to find the critical points given this function, the square root of x squared minus 4. Okay? Okay. Let's move on to the next example. Okay. The next example here says find the extrema. Okay. When I say extrema, it means the extreme value, the minimum and the maximum. Find the extrema of this function f of x equals to x cubed minus 3x squared minus 9x plus 15. Actually, this is our previous example, but we have here an additional. On the interval, now we have an interval, close interval 0 and 4. Okay, so how do we find the extrema? Extrema means we will find the minimum and the maximum. Okay, so we need to evaluate this function at 0 and 4. Question is why? Why do we need to evaluate this function at point 0 and point 4? Because we are given an interval and it is a closed interval. And remember, when you have a closed interval, the endpoints are included. So in other words, 0 and 4 will be considered also as critical numbers. Okay? So the first thing that you should do is to evaluate the original function with point 0 and point 4. So you will find here f of 0. Okay? And f of 0 means 0 cubed minus 3 times 0 squared minus 9 times 0 plus 15. Okay? And what's the answer? The answer is, of course, 15. 0, 0, 0. We'll be left with 15. So, our f of 0 here is 15. Okay? How about f of 4? I'm talking here of the endpoints, 0 and 4. So this will become 4 cubed minus 3 times 4 squared minus 9 times 4 plus 15. Okay, and then evaluate. I have done this one before. You may pause the video and solve, and my answer is negative 5. Okay, so from the previous example, so this one represents the first critical number, right? The critical numbers here are, I will write here, the critical numbers here are 0, 4, okay, And in our previous example, if you could still remember, in the very first example that we have a critical number as 3, okay, 3 and -1. Okay, by the way, we have obtained that 3 and -1 by finding the derivative and setting to 0 and find the value of x. Okay, so that's the value, -1 and 3. So how do we find the extrema? When you say extrema, the highest or the lowest. So I would suggest that we'll make a table. Okay, why? Because it's easy for us to identify the maximum and the minimum if we have the table. So we have here x values. For example, our x values are the critical numbers. So what are the critical numbers? And the y values are its corresponding y values, of course. So we have 0, 4, 3, and -1. So when you find f of 0, what's the answer? F of 0 is 15, right? When we evaluate f of 4, what's the answer? F of 4 is -5. When we evaluate last time, f of 3, or you will substitute 3 to the original function, we have arrived last time at -12. Okay, -12. Okay, and when we have solved last time also for the ordinate of -1, we have arrived at 20. You may review our previous video and you will look there that we have here 3, -12, and -120 as our critical points. Okay, so where is the minimum and where is the maximum? Where is the maximum first? The highest number, 20? Agree? Not, yes, 20 is the highest, but this is not an extrema. Okay, not extrema because 20 is not in our what? In our interval. This one, our interval is -1 here. So -1 is not included in 0 to 4. So it violates the condition in the given function here. In this given function, we are only allowed for x values from 0 to 4, and -1 is not in the interval of 0 to 4. In a number line, if this is 0, this is -1, and this is 4, we're only allowed for the values here. And obviously, -1 is outside of the interval. So we are not allowed to use the ordinate coming from -1 because it is not included in the given interval. So 20 is not an extrema because it is not in the interval. Okay, so what's the next highest point? After 20, we have 15. 15 came from x value of 0. Is 0 in our interval? Yes. So this is now our maximum. Okay? And which one is lowest? -5 or -12? Of course, -12 is lesser than -5. So -12 is our minimum. Okay? Why minimum? Because it is the lowest value of y. And this y came from 3. Is 3 included in our interval? Yes, because 3 is in between 0 and 4. So, in this example, our maximum is 15, our minimum is -12. Or, if you would like to say that in a critical point, our maximum is indicated by 0, 15, and our minimum is 3, -12. Okay, so the problem, since the requirement is only find the extrema, and here are the extrema represented by a maximum and a minimum. So far we have discussed 2 more examples about finding the critical number, the critical points, evaluating the original function to get the critical point, and to find the extrema, the maximum, and the minimum. Hope that this video will help you in the future. More of this when we have the first derivative test. Thank you very much and see you soon in the next video.